Hi, I'm Tim Gilbert. I'm an instructor here at Keuka College in BUS320, and I wanted to talk to you about exploratory data analysis. This assumes that you understand the idea of percentiles, where you would calculate maybe the 25th percentile, the 75th percentile. So if you don't have a good feeling for that, you should go back and review it. But we're going to talk about outliers and introduce the idea of Boxplots under the heading of EDA, or Exploratory Data Analysis. And an outlier lies extremely far away from almost all the other data points. It'll distort our mean, our standard deviation, and histograms. So it's nice to have a technique that will allow us to evaluate that. First, there's going to be a 5-number summary, which sounds a little daunting, but it's really the min and maximum value and the median plus a first quartile or 25th percentile, which is the same as Q1, and Q3, which is the 75th percentile. Well, let's take a look at that on one of our box plots. This is a data set that you'll be seeing in a little more detail in the next slide. But for this data set, the median was 33.5, the min was 21, the max was 80. Q1, or 25th percentile, turned out to be 28, Q3 39.5. So that's the 5-number summary, and it tells us that 50% of the data lies between 28 and 39.5 because that's the 75th percentile. That's the 25th. That would make 50% of the data lying inside the box. Now here's 2 data sets, Academy Award winners over 75 years for women and men, and you see part of the spreadsheet there. I did this on Stat Crunch in Math Excel. You could also do the get the calculations completed on Math Excel, Microsoft Office Excel. Or you could do it on Stat Disk, which is in the back of your book on a disk that can be downloaded. The program can be downloaded on PCs or Macs. So we can see a 10-year bias between the actresses, 33.5 versus 43.5. The range, let's see, the range is the same. The min is 21, 31, female to male, 80 to 90, female to male. Q1 is 28 to 38, and Q3 is 39 to 49.5. Those 80 to 90 were maximum values. So there's the box plot for females, Q1, median, Q3. Now here it is for males, Q1, median, Q3. And there's the minimum and maximum values. So the box plots really reinforce this bias between females and males in winning Academy Awards. Let's answer another question, which is 80 years of age and 90 years of age, are they outliers to their respective data sets? We have a method to calculate that, and a data point's an outlier if it's greater than 1.5 times the interquartile range. Sounds a little daunting, but don't worry, it's pretty intuitive. The interquartile range is 39.5 for women. That's the 75th percentile. You take that, subtract Q1, and you've got the range in here. So it's 11.5. 11.5 years of age between Q1 and Q3. Multiply that by 1.5, just this constant that's given to us by the statisticians. It equals 17.25. So it says if I add that to the top quartile, here's my boundary to consider anything above that age to be an outlier. So this 80-year-old is an outlier in winning an Academy Award at 80 years of age. And we can subtract that 17.25 and get 10.75 on the lower end, so there weren't any outliers for the youngest actress. So in this section we've looked at exploratory data analysis, the effects of outliers, the 5-number summary, and we've been able to determine outliers. So what I would invite you to do is to come back into the presentation, look at the males, 31 for the minimum, 90 for the max, 38 and 49 and 43.5, and do the calculations and determine if 90 is an outlier. And remember, this range, 28 versus 39.5, looks to be the same range as from women to men. So that's just a tip in your calculations. So try doing that and check it out with your instructor, and you'll see if 90 years of age is an outlier, and it'll give you a little bit of practice. So I'll be talking to you again online about other topics. Take care now.